Alright, we're back with the third of our series of videos where we're doing some derivative problems here, and we're looking at this problem right here. Now, we want to find the first derivative, the second derivative, and the tangent line when x equals 1, and then graph all those things. That was our set of directions that we had. So, when we look at this function, we see that when we're evaluating it, we raise to the powers here, we multiply and add and subtract in the numerator, raise to the power of the denominator, and the last thing we do is divide. So with it in this form, the thing that we would start with would be the division rule, the quotient rule. However, I think it's going to be better if we manipulate this function a little bit first before we try to graph it. First of all, I can make the cube root of x before we try to compute any derivatives. Let's write this as x to the 1/3 power. Now we can divide this into each one in the top, and we get 3x to the, well, let's see, 5/3 minus 1/3, 5 minus 1/3. 5 is multiply top and bottom by 3, that's 15/3 minus 1/3 is a power of, what would that be? That would be 14/3 plus 7. Okay, and it's going to be a power to some thirds. Let's see, 1 minus 1/3, that's 3/3 minus 1/3 is 2/3 for the power here. And then finally, minus 5, and then we have x to the negative 1/3 for the power. Oh, okay, so that is another way to write f of x. That way is going to be a lot better for finding the derivative. So if we want to find the derivative, now we can just apply the, I'll get this right in a second. We can apply our little rule for the sum of power functions. So we take the 14/3 times 3 is 14. Subtract 1 from the power. 1 is 3/3. 14/3 minus 3/3 makes that 11/3. 2/3 times 7. Let's see, that's going to be, let's see, 2/3 times 7 is 14/3. Okay, and then we subtract 1 from the power. 2/3 minus 1 is 2/3 minus 3/3, which is negative 1/3. Okay, so we got negative 1/3 times negative 5 is positive. 1 times 5 is 5 in the numerator, and 3 in the denominator, so that's 5/3. Negative 1/3 minus 1, that's negative 1/3 minus 3/3 is negative 4/3. And so there's the derivative. Now, this is also equal to some other ways of writing it. 11/3, if we make it into a mixed number, if we divide that out, 11 divided by 3 is 3 remainder 2. So that's 3 plus 2/3. Okay? And similarly, 4/3 is, well, let me do this first. Let me take this x to the negative 1/3, move it to the denominator, and make it x to the positive 1/3. Let me do the 3 and 2/3 and maybe in the next step. And then we take this x to the negative 4/3. I want to move it to the denominator here and make it positive 4/3 for the power. Okay, maybe we'll leave it like that for a second, and let me rewrite this. Okay. This is 14. This is x cubed times x to the 2/3. Plus, I think I'm going to make this a big fraction this time, 14 over 3 times the, no, not square root, cube root of x. There it is, cube root of x, plus, let's just put this here, 5 is in the numerator, and then we have 3 times the, well, 4 is 1 and 1/3, so the 1 would be here, and the 1/3 would be a cube root of x. So this x to the 2/3 power is the cube root of x to the 2nd power. Now originally they had it as one fraction, so maybe we could write this as one fraction. They didn't mind having a root in the denominator, so that's no problem. But we but we like to make it one fraction. And so we need a common denominator, and this right here is the common denominator, 3x cube root of x. So to get that, I need to change other things that way. So I need to multiply the top and bottom by x here. I need to make this a fraction, okay, with that same denominator. But notice I have to multiply the bottom by all of that, so I need to multiply the top by all of that as well. Alright. Alright, so let's see what if we can clean this up a bit. Okay, so let's see, 14 times 3 is 42, right? And then so the 3's gone. The x times that x is x to the 4th now. The cube root of x times the cube root of x squared is actually another x. So this is x to the 5th. Okay. Plus the 14x plus the 5. So we could see it that way. Now maybe if we'd done the quotient rule, we might have gotten there a different way, but we should have gotten the same answer. Okay, or let's do it with the quotient rule. Okay, we'll see how we might have done it with that way. Now, actually getting the derivative, we actually had the derivative right here. Well, the rest was just manipulating the form around. But what if we have this right here, and we want to do it with the quotient rule? Okay, so we want the derivative of this. So it's we have the way the quotient rule works, it's the bottom times the derivative of the top, okay, minus the top times the derivative of the bottom over the bottom squared. Okay. Let's see where this gets us. Alright, so here we get 15x to the fourth. We're taking this derivative here. Plus 7 plus 0. And here we get, this is x to the 1/3. So I'm still going to have to do, think of this as x to the power 1/3 in order to do this part. Okay, so now when I do this derivative here, I get the 1/3 times x to the one smaller power is negative 2/3. Okay, so there it is. We have the derivative. Maybe not obvious that's what we have up above, so let's work with this a little bit. Okay, so I need to get rid of the let me rewrite this here as 1 over x to the 2/3, which I could actually write as 1 over, and actually, you know what, I'm going to write this bottom, pull the power inside instead of the outside like that. And that's what's in the bottom. Same thing's in the bottom there. Now I've got fractions inside my fractions. So I'm going to take the whole thing and multiply by that denominator, which is really just this again. I'll multiply the top and the bottom by that, so that I don't have fractions inside fractions at the next step. Okay, well, in the bottom, that's the cube root of x to the fourth. Okay, the cube root of x squared times the cube root of x is just x. That's kind of nice, fortuitous there. And this, that's times the first term. All this is a second term. This one is going to cancel out with this, which is why we did it. Oh, actually I should have multiplied by 3 as well. Here and here, so that I can get rid of that 1/3 as well. And that means I'm going to have a 3 here. Okay, I hope this is working out right. Alright, let's see what happens next. Now let's see, let's do some multiplying out here on the top. So 3x times 15x to the fourth is 45x to the fifth. And then we've got 3x times 7, so that's plus 21x. So that took care of all that. And then we take this guy here, and we want to distribute a minus 1. So it just changes all the signs. So it's minus, minus, plus, and 45x to the fifth minus 3x to the fifth is 42x to the fifth. 21x minus 7 is 14x. And then plus 5. And the cube root of x to the fourth, the power is bigger than the root, so we divide by the root and we get 1. So this is x to the first power, and then the remainder of 1 power remains there, x times the cube root of x. Let's see how closely that looks to what we did before. Oh yeah, there was a 3 in the bottom somewhere. I think I lost that somewhere on the way down here. Where did I lose it? There's the 3 right there. So it should be here. Okay, so 3x cube root of x in the bottom. Is that what I had? So, hope so. Yeah. 42x to the fifth plus 14x plus 5. Is that what I had in the top here? Well, if it is, I'll be real happy. Yes. That's exactly what I had in the top there. So I got the same thing both ways. So you could do that either way. I kind of prefer the first method, but the other one does work. Especially if I'm going to go on and do another derivative, I think it's going to be easier if I take this version. It's a sum of power functions to find my second derivative. And we can manipulate the form after the fact if we want. Okay. So when we do the second derivative, we've got 11 thirds times 14. Well, 11 times 14 is 154, and that's going to be thirds. And then you subtract 1 from the power. So 11 thirds minus 1 is 11 thirds minus 3 thirds, which is 8 thirds. Negative 1, negative times this is makes a negative. Negative 1/3 times 14 thirds is negative 14 ninths. And then the power goes down 1. Negative 1/3 minus 1 is negative 1/3 minus 3 thirds, which is negative 4 thirds. Negative 4 thirds times positive 5 thirds is negative 20 ninths. And the power goes down 1, so that goes down to negative 7 thirds. So there's the derivative. Can we write that a different way? Well, yeah, we can. One way I can do this is we can factor out the smallest power, which is x to the negative 7 thirds. I want to show you sort of a different way of doing this. And we can factor out 1/9. So I can factor out a 1/9, and I can also factor out an x to the negative 7 thirds. Okay, so when I factor this out here, let's see what happens. So when I divide everything by 1/9 or multiply by 9. So the 3 is going to cancel, and I'm going to get 3 times 154 here. 3 times 154. Some scratch paper here. 154 times 3. Or I could do, you know what, I'll just use a calculator. Well, I can do it with scratch paper. 154 times 3, 12, 16, 462. That's sloppy writing, isn't it? 462. Or I could have just done it on a calculator, I guess. 154 times 3. 462. The next time the 9 is going to cancel out completely, so this is 14. Oh, I need to take care of, well, I'll go ahead and do all the 9s, and then I'll distribute this part too. And the 9 cancels here, so this is just 20. Okay? Actually, there's some more things I could have done too. When I'm dividing this by x to the negative 7 thirds, that's the same as multiplying by x to the positive 7 thirds. So this becomes 8 thirds plus 7 thirds is 15 thirds, which is just 5. X to the 7 thirds times x to the negative 4 thirds is x to the 3 thirds, which is just x to the first power. And then this x, then that one cancels out. And actually, notice that these all have a common factor of 2, so I should have actually factored out a 2/9. So let's go ahead back and do that now. So I can divide all these by 2. 231, 7, and 10. Okay, so now This may be a slightly easier way of doing this than I simplified the last one. So that becomes the numerator, along with the 2, which is in the numerator. The denominator has a 9, and we have an x to the 7/3 in the bottom, which is now a positive 7/3 power. Seven-thirds power is 2 and 2 plus 1/3. We make it in mixed numbers. And so now if I make it radicals, that's an x squared times an x to the 1/3. X to the 1/3 is the cube root of x. So that's f double prime. Okay, well that took a little bit of work there to get that. Now we also want to find the tangent line, so we want to take some version of this here, let's say this version, the original one, of the function f, and evaluate at the point where we want to find it. And in these set of videos, I've just always been picking 1, just to pick something. It could have been any point. So we can do that. And let's see, I think we can simplify this. The cube root of 1 is 1, so that's a 1 in the denominator, that's nice. So in the top we just get 3 plus 7 minus 5, and it's all over 1, so that is 5. So f of 1 is 5. Now let's find f prime of 1. Well, you know what? This is as good as any to use for f prime. And then plug in the 1 here, here, and here. One thing nice about using 1, doesn't matter what those powers are, they're all 1. 1 to any power is 1. So these things, and since they're just multiplying by 1, these things might as well disappear. And so we get a common denominator of 3, and we get 14 times 3 is 42 thirds plus 14 thirds plus 5 thirds equals, what is that? 40, 50, 61? 61 thirds. Okay, so that's f prime at 1. So there's our slope. So our equation of our tangent line, t of x, or y, equals the slope, m, which is the derivative, times parentheses, x minus the x-coordinate of the tangent point, which is 1, plus the y-coordinate of the tangent point, which is f of 1, which is 5. So now we have all of our formulas. Okay, let me go back over those. You might want to write them down. So there's the original f of x, which is 3x to the 5th plus 7x minus 5 over the cube root of x. We have the derivative, which we've saw it in a couple different forms, but say the final form might be 42x to the 5th plus 14x plus 5 over 3x times the cube root of x. We found it 2 different ways. The second derivative is, here it is, 2 times 231x to the 5th minus 7x minus 10 over 9x squared times the cube root of x. And the tangent line is y equals 61 thirds times x minus 1 plus 5. Okay, so now let's graph these things. Pull up a graphing utility. Okay, so you have to look where you wrote these down somewhere, and let's put the original one in. Y equals 3x to the 5th plus 7x minus 5, close parentheses, divided by, and this is x, the cube root of x, so I'm going to have to do that as x to the power 1/3, because you put that 1/3 in parentheses. That's supposed to say power, not times. Let's see, power. Okay, so there's the original. Wow, that's kind of strange, but there it is. Okay, we'll put it blue. Alright, so that's the original function. Alright, now let's see what the derivative looks like. So the derivative was y equals, parentheses for the numerator, 42x to the 5th plus 14x plus 5, that's the numerator, close parentheses, divided by the denominator, open parentheses, 3x times the cube root of x. So it's times x to the power 1/3. Close the power, close the denominator. Graph that, and we've been graphing the derivative in red, so we'll make it red. And then we will do the second derivative. The second derivative is, okay, here we go, y equals, okay, parentheses for the numerator, 2, parentheses, 231 x to the 5th minus 7x minus 10, close that polynomial, close the numerator, divide by, open parentheses, the denominator is 9x squared times x to the parentheses 1/3, close the parentheses on the power, close the denominator. That should be the derivative, and we've been doing purple for the derivative. And then hopefully we have the tangent line, y equals, let's put this fraction in parentheses, 61/3, okay, times, parentheses, x minus 1 plus 5. Okay, so if we did this right, the tangent line should touch the original function right at 1. That's good. Okay, now let me just kind of put the labels where they go. So f of x we're going to place on the blue one here. The f prime of x, let's place that label right here by the red one. And let's place the f double prime label, it's on the purple one, where's that going to be? Maybe right here. And then we'll place this somewhere on the tangent line, maybe right there. That looks pretty good, although we might pull it in a little bit on the sides. So what if we only went from -4 to 4 on the grid range? Yeah, that's not bad. Well, there's a lot of stuff going on there. Let's see if it makes sense. So it looks like our tangent line is looking good. The original function looks like it's decreasing in here, so the derivative is negative. The derivative touches the axis right here, so that's where the minimum is. It's right above that. And then the derivative starts going, the function starts increasing again, so the derivative is positive. It looks like the original function has a vertical tangent line at x equal, a vertical asymptote at x equals 0. It's undefined, and so all of the derivative and the second derivative are undefined there. They have asymptotes there as well. Then we've got the original function is increasing everywhere else, looks like, so the derivative is always positive. Okay? The second derivative is 0 right here, so that means the first derivative has a minimum, and there's an inflection point right below that right there on the original function. So it goes from concave down to concave up right there below where that purple one crosses the axis. Over here, the second derivative is always positive, so the first one is always concave up, which it is. Over here, the second derivative is negative, right in here, so the original function is concave down, and then it goes back to positive for the second derivative, so concave up. Of course, where the second derivative is positive, the original function is concave up, and the derivative is increasing. So it appears that everything is looking pretty good on the graph. So it looks like we probably didn't make any mistakes with that. So let's go here and put our graph in on our answer. And so there we go. So in our next problem, we're going to be looking at f of x equals the absolute value of 25 minus x squared. So you might want to try to work that one out before you come back and watch the video.